Hello everyone, I am Ankit Maharana. I am currently pursuing my Master of Science in Applied Geology at Department of Earth Sciences, IIT Roorkee. I'll be giving a lecture on the topic Stereonet and Geological Map. This is a part of our curriculum and the coursework under the guidance of Dr. Sandeep Bhatt, who is an assistant professor at our department. So we'll be discussing in depth about these topics. Going to the content, I'll be covering this whole content on two parts. First, will be in the part 1. I will be covering the geological map, topographic map, profile construction, visual and stuff. In the second part, we'll be discussing about the stereonet, stereographic projections, common tags using stereonet. These are some of the things. Moving further, what is the orientation of different elements and why is it actually important in structural geology is very crucial to understand before moving further. So understanding the orientation of rock layers is very crucial in geology. Strike and dip measurements, that is, the strike is the compass direction of a horizontal line on the plane and dip is the angle that the plane makes with the horizontal, and the true dip always measured at the right angle to the strike. So strike and dip are the basic things in the structural geology before moving forward. So these are then plotted using stereo nets to help visualize this 3D data on a 2D plane. When used with geological map and say topographic map, they are key tools for interpreting structures, mapping formations, and building accurate subsurface models. So there is this structural workflow that when actually the geologists go to the field, they measure different structural elements, and it basically first we do the field measurements of the orientations, then we make the geological map of the area, then we plot the shear-net, that is a 2D projection actually, and finally we do the structural interpretation. So in this lecture, we will be mostly covering the geological map and stereonet plot. So what actually geological map is? Uh, a geological map is two-dimensional representation of the geology exposed at the Earth surface, showing the spatial distribution of different rock types and geological structures, typically accompanied by symbols indicating the orientation of rock layers and other features. So for example, just for example, I know these fonts are quite not quite visible, but just for example, I have shown a geological and mineral map of Odisha that is prepared by GSI. So you can see different types of lithologies here are color coded with different colors. That's what I am trying to say here, that for different lithology we have taken different colors to actually indicate, and this is actually how geological map looks like. Sorry. So uh, then in geological mapping, the role of scale is very important. It is compiled from many observations from the outcrop in the field. Maps might be 1 is to 50,000 or 1 is to 1 lakh. It can be anything as I have shown here. The different scale like small scale, medium scale, large scale, or very large scale. So, uh, what this actually means? This means one unit on the map equals to that many units in reality. Here 1 is to 50,000 means one unit on the map is equals to 50,000 units of that in reality. So that is the geological mapping scales. Okay, so they basically provide the base onto which this superimposed orientation data, which leads us discussing topographic maps. So we'll be talking about the topographic maps just after some time. So these are the symbols to plot the structural features. That these symbols are basically used along with the geological map to show any structural features that we have seen in the field. So these are some of the features, like these are the symbols for the strike and dip, for the vertical weights, foliations, fractures, fault orientations, launch directions. Every thing is listed here. You can take a screenshot and use that screenshot further. So this is just for your information. So what is topographic map? Topographic map, that we in short we say topo maps, represent numerically the complex curves and elevation of our surface with contour lines. So what is contour lines? Contour line is basically a line joining points of equal elevation on a surface, which represent the intersection of those curves with horizontal surface at regular intervals. So I have a quite good example here. So this is the line from here, and this side has a steep slope, and this side has a gentle slope, and this is the line of the elevation above the sea level. Okay, so when we prepare the contour map, these steep sides, the from the elevation lines, we take the projections here into the contour map. When the contour map is prepared, you can see the steep side has a quite the contours are very close. On the gentle side, the contours are very uh, distance apart. And for each elevation, we have different value of contour like 0, 500, 1000 up to output. Okay, so these are some of the rules or characteristics of contour lines that we should discuss here. Every point along a contour line is the exact same elevation. Means this circle, if you are talking about, in this circle or this contour line, this may be a circle or not, but along this line, the value should be always 2000. Along this line, the value should be always 1500, whatever it is. Then contour line must be closed on itself. Contour line can never cross each other because we are talking about elevation, right? So they will never cross each other. You can see the no contours cross each other. So the map distance between two adjacent contour lines may vary, but their elevation difference should remain constant. As you can see, here 2001 is 1500. These are quite distance apart, but here they are quite close. But the elevation still is the same. The elevation difference still is the 500. So this is something we should take care of while understanding these concepts. So topographic index map. So in Indian context, this is the mapping system we can see. So just for understanding, this is a quite 11, 12 thing that is discussed in NCRT, but I will just give a brief overview that how we actually count these grids. So this is a topographic index map, and in Indian context, it is divided into different grids of numbers. You can see 37, 38, 39 according to the scales, but each grid has has numbers, assigned numbers. Okay. So each grid is divided into 16 subgrids, that is basically A, B, C, D up to P. Okay, and each subgrid that is the assigned by a letter is also divided into further 16 numbers. So 1 to 16. So if I say for example 55D7, so we have to find 55D7. So 55 is here. So 55, and when 55 grid is divided into subgrid, D is here, and if we zoom to D, you can see the numbers 1 to 16 here. So I was asking 55D7, so D7 means this subgrid I am talking about. So this is how the analysis is done, and these are some of the symbols that is used for showing different features. Some normal features like roads, rivers, and hospitals, and further you can see in the picture. So these are the some of the basic things before going into more detail. So topographic map and how to actually construct a profile. So here we have a diagram from Billings illustrating how to make a topographic profile. Suppose we want a cross section of the terrain along line A and B on the map. A and B on the map. So we take a strip of the paper as shown here along and align it along A and B. We mark the points where the paper crosses each contour line. So here is a contour, here is a contour, here is a contour, and each have specific value. So we mark that contour and add that specific value here. And on the left side of the profile paper, we set up a vertical scale that actually matches the map's vertical scale. Okay, so then we transfer the elevation marks from the contour intersection on the profile. By connecting these uh, points smoothly, we create the profile of the land surface along AB. So here you can see that along the, so we have the contour values here, 0, 200, 400, 600. This is the paper strip that we have used. We just take that paper sheet, mark these points on the map with along with that specific value of contours. Like this point is of 200 contour, so we mark the point straight in 200. This is 500, so we mark the point as is here in 500. So we have different points. We freehandly we connect those points from like this to this, and this is the profile that we wanted. This is the topographic profile, and here you can clearly see from this map you cannot identify that which side is gentle and which side is steep, though we know the close ones are the steep. But for better clarity, here you can see the actual landform, like this side is very gentle slope and this side has a steep slope. So this is how we construct a topographic profile in a map. Okay, moving further, structural geometry in response to topography. Okay, so here we will be discussing the rule of V's that we said, and the rule of V's helps us infer deep directions of inclined layers from how they crop out around the valleys and ridges. On this slide, we have several cases. Let's discuss that. The vertical strata. Okay, so there is no drift. The strata is vertical. Such layers cut across topography without forming V shapes. So you can see there is no V's in this picture, and you will see straight vertical weight symbols and no systematic V. Okay. In the second diagram, we can focus that these we are talking about the horizontal strata. So these lay flat. So contour lines of constant elevation intersect them as parallel lines. You can see intersect them as parallel lines. Okay. So these weights follow the contour lines. This weight follow the contour lines exactly like they form a concentric pattern around the peaks or pits, but essentially look like the topographic contours themselves. So you can see here. So these follow the contour line. Now moving on to the inclined stratas. So here is our third case, inclined layers dipping upstream. So if the downstream side is towards the river source, and here one thing is, if the deep angle is greater than the stream slope, so the V is pointing upstream. So this is another case. So inclined layers dipping downstream. So here still the deep angle is greater than the stream slope. So there is this V pointing towards the downstream side. Okay. The only exception in the V's rule, when the inclined layers is like deep angle is in the inclined layers, the deep angle is less than the stream slope. So V is always pointing towards the upstream. This is the only exception in the V's rule. So these V's rule as the basic concepts in the topographic map, and this help us learning the upstream and downstream side better. The V's. Okay. So moving to the next topic, that is the determining strike from the topographic map patterns. Okay, as I have discussed earlier, strike is basically the compass direction of a horizontal line on a planar surface. Okay, so on a map, we don't see horizontal lines directly, but we can infer the strike by drawing structural contours. So the idea is basically if an inclined bedding plane intersects the surface at several points of known elevation, that is from the topography, so we can draw a contour line along the plane. So in practice, if you see the same rock unit exposed at different places with different elevation contours, you can connect those points that lie on the same bedding surface at equal elevation. So this connection become the structural contours of the bed. So the trend of these contours is the strike direction. So, but and connecting those points, there is a rule or fundamental principle. We said that we have at least 3 or more points. To then we can actually draw the structural contour that allow us to determine the strike. I will better explain with in a diagram. So this is a map basically, and these are the contours. These are the contours like 70-meter contour, 60-meter contour, 50-meter contour, and this is the contact. Okay, so take 3 points in 60-meter contour. So this is a point. This is a point. Okay, this is the point. Another point is this. So we got 3 points of 60-meter, and we connect them. Okay. So after connecting, you can see that this is how for 70-meter contour, 70-meter structural contour, 60-meter, 50-meter, 40-meter. So these are the way how we can determine the strike from the topographic map patterns. So now let's discuss how to determine dip from these map patterns. And I have already discussed what the dip is. So dip is basically the angle between our planar feature and the horizontal. And on a mesh, once we have the strike value, we find dip by looking at vertical change over the horizontal distance between the structural contours. So let's simplify this. So we have this structural contour map here. So of different values like 600, 550, 500 and 450, so on. And at first we have to identify two structural contours. We choose any two structural contour lines on the same geological plane. And these lines represent equal elevations. Okay, so let's take 600 and 550. Okay, then we have to draw a line perpendicular to the contours. So this is basically the dip direction. So the steepest descent across the plane. Okay, so use a ruler or anything to draw a straight line. Like here, we'll draw a straight line perpendicular to the contours between the two elevation points. And using this map scale, we measure the horizontal distance between the two contours along the dip direction line. Okay, so if we get, like you say, 2 centimeter, so we have to convert that to 2 centimeter value to the map scale, 1 is to 50,000 or whatever it is. So that is basically the distance between the contours and the map. That is converted to the map scale. That is the actual scale on the ground. Okay, so we got the distance between contours and the map. What is contour interval? Contour interval is basically the elevation difference. So 600 and 550, the elevation difference is 50 meter. Okay, so the contour interval will be the elevation difference, and the distance between contours and the map will be the actual distance in the map, like into the which is converted to the map scale. So these two values ratio gives basically the tan value of the dip angle. This is how we can actually determine the dip angle. So this is all for the geological map and the topographic map. This is a basic lecture. There is much more into this. If we draw a topographic profile, there are ways like how can we can actually draw dips on the topographic profiles, specify different stratas, specify different folds, faults. There are much more into this. You can explore yourself. So for the basic information, these are the basic things. And in the next part, we will be discussing about the stereographic projection and stuff. And for the geological map and all, this is it for the lecture. Thank you.